Our contribution is entitled Numerical Investigation on Strengthening Steel Beams with Web Openings using GFRP. Interrogation of utilities via web openings in steel floor beams is typically inevitable in modern frame structures. Traditionally, additional steel plates are welded to the opening regions to reinforce and stiffen them. This not only creates practical issues, but can also introduce residual stresses. Since the strengthening of steel beams with web opening using FRP is a novel technique, today there are no guidance or manual to use. The idea of this study is to explore the ability of low-modulus fiber GFRP for the strengthening of steel E-beams with web openings. The previous published experimental test on strengthening steel beams using CFRP was used to validate the proposed numerical model capable of occurring important phenomena such as debonding between FRP and steel. Using the validated numerical model, the verified specimen was strengthening using pultruded GFRP laminates. 4 strengthening configurations were considered using pultruded GFRP plates and different GFRP profile shapes. In addition, the influence of different GFRP laminate thicknesses was investigated. The results were disputed in regards to strength improvement, load deflection response, failure mechanism, bond behavior, and compared to the previous CFRP strengthening data. The creation of rectangular web opening in the midspan of the beam resulted in strength decrease of 12% compared to the initial beam. Due to the presence of various GFRP strengthening pattern and different profile thicknesses, different percentage of strength and stiffness restore was noted, ranged from 25 to 45%. According to the strengthening pattern and GFRP section thicknesses, different failure modes were also noticed after steel yielding, causing and debonding between specimens and GFRP sections. Instead to CFRP, the GFRP strengthening technique proves to be an effective approach in practice for recovering the stiffness and the strength of steel beams with rectangular web openings. This approach not only assists to restoring the beam's capacity, but also provides a boost of strength over the original solid beam. The findings suggest that GFRP is a suitable, practical, and economic way of strengthening.